Here we are, chapter 2, rational numbers. Ha ha ha. Are you ready? I'm totally ready. This is one of my favorite subjects because I love talking about numbers, which of course makes me kind of weird, super nerd. But hey, that's why I have the job I have. Oh, I guess. All right, so here we go with your notes. Your learning target today is that I can write rational numbers as fractions in simplest form and as decimals. Well, boom. That's it. So we got to do a lot of fraction decimal stuff today. Alrighty. So most of this should be review. We're going to throw some challenging ones at you to kind of get your brain going. Need you to practice doing this without a calculator because this up here is the best calculator you've got. Here we go. So first of all, vocabulary word. What is a rational number? Okay. Well, a rational number is basically a fraction. Okay. And when we write this fraction, okay, we got the fraction bar, and you have a numerator and a denominator. And I'm going to use two variables, okay, like the letter A and the letter B, like this, okay? And when we write it as a fraction this way, this number has to be an integer, meaning a whole number. Remember last chapter we talked a lot about integers, like 1, 2, 3, 4, 5, 0. -1, -2, -3, -4, okay? These are integers. And then your bottom number is also an integer, but here's the deal. It's an integer that cannot be 0. That is totally illegal. It's not allowed. Nope, nope, never, never, I can even get my no button out and say,
for the last time, no.
It's just simply not allowed. You can't do it. Nope. This is what a rational number is, okay? It's a fraction. You got a numerator, you got a denominator. All right, then I think I have this term up there called relatively prime. Relatively prime. Okay, now, you think back to before and we talked about prime numbers. Prime numbers were basically numbers that you couldn't factor anymore. The only way to factor them was just the number 1 times the number itself. That's what it meant to be prime. So, for example, don't write this down, but just to remember what prime numbers were. A number like 3 is prime because the only way to break it up with multiplication is 1 times 3 using whole numbers. A number like 5 is prime because you can only write it as 1 times 5. 4, 4 is not prime because I could write 1 times 4, but I could also write it as 2 times 2, okay? All right, so that's what prime is, but what does relatively prime mean, okay? These are two numbers, and they basically have no factors in common, okay? So if I were trying to break them up, okay, no factors in common. And then I'm going to add a little exception here, okay? Except 1, because 1 can go into anything, okay? Two numbers, no factors in common, okay? Basically, if you have these two numbers as a fraction, it's like simplest form. That's what's happening, okay? So I'm going to add that in there too, simplest form. And then that's kind of another way to say that these two numbers are relatively prime. All right, so let's hop on the review. And now don't start whining about fractions. Not allowed. Fractions are your friends. Seriously. Here we go. Okay, look at this model for 12/15ths, just so you kind of remember the picture here. I have a shape. It's divided into 15 equal parts. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 12 of them colored in. So to represent this fractionally, 12 out of 15. Over here, I have a picture that's the same size. I've drawn it or divided it only into 5 pieces, and I have 4 of the 5 pieces. But if I laid these two on top of each other, they're exactly the same. These two fractions are exactly equal to each other. Different names, but that's because this guy isn't in simplest form. So when I ask you about simplest form, you need to kind of keep chipping away at it until you have two numbers that are relatively prime. 16 and 80, they share a common factor. Your job is to keep kind of chipping away at this thing until you end up with something in simplest form. So let's look at 16 and 80. What do they have in common? I usually start with the 2 and go from there. Okay, let's say I only saw a 2 in here first. I would say, well, I divide by 2, I divide by 2. Now I would get 8 in my numerator and 40 in the denominator. Oh, keep going. Okay. And in fact, maybe you see you could go even better than a 2, that you could go by a 4 or an 8. And if you see that, go, go, go. Don't wait for me. I get 4/10. Keep going. Keep going. Okay. 2/5 in simplest form. There you go. Okay. 18/27. Okay. 18/27. Let's see. 2 works with 18. 2 is a factor, but 27's odd, so 2 is not a factor. So I guess we got to go for a 3, which works. Yes, sirree. Okay. 3 over 3 is 1. That's why it's legal to do this. I get 6 over 9. Oh, keep going. Okay. You cannot stop until you are totally done. There you go. Look at 15/21. Both of them are odd, so a 2 isn't going to work, but I bet a 3 will. Yupper dupper. I get 5 over 7. Done. 5 and 7 are numbers that are relatively prime, no common factors. 2 and 3, relatively prime. 2 and 5, relatively prime. Good. All right, now let's talk about decimals. Okay, so we got the bit. If we get a fraction, okay, get the fraction in simplest form. Decimals that terminate or repeat are rational numbers. Okay, terminate means it stops, it ends. Okay, so that means, remember, fractions is another word for a rational number. So that means every time I give you a decimal, you can turn it into a fraction. Let's see. 0.8. That's lazy math way to read that. This is really in the 10ths place. So if I was going to read it properly, as I should, I would read this as 8/10. Oh, duh. That's a fraction. 8/10. Ta-da! That's a fraction. Put it in simplest form. Done. Move on. Next one. 1.25. Oh, stop doing that. I should read this properly. 10ths place, 100ths place. This is 1 and 25 hundredths. Okay, if you have a whole number in front, just write that as your large part of your mixed number. And then take the decimal part and read it properly, and that will give you the fraction. Not in simplest form yet. Don't forget your whole number. 25 hundredths. Think money. 1/4. Next. Okay, let's go to town. 5.37. No, 5 and 37 hundredths. Look at this. Can you simplify it? 2, a 5. Nope, you're done. 0.622. Really, that is 622 tenths, hundredths, thousandths. Okay, let's start chipping away at this. I get 311 Okay, dividing by 2 is like taking half of something. That's 500. I'm going to tell you right now that's in simplest form, and I can tell you that quickly because when I have decimals, everything is based on 10, and 10 only has 2 factors, 2 and 5, or some combination thereof, okay? Thousands is a combination of a whole bunch of 2s and a whole bunch of 5s. If a 2 doesn't work in 311, no, because it's odd, and a 5 doesn't work because it doesn't end in a 0 or a 5, you're done. You're done. All right, look at this, 8.75. 8 and 75 hundredths. Okay, keep the 8 out in front, simplify the fraction. 3/4. I like that, I'm thinking of money. 0.26, no, 26 hundredths. Okay, factor a 2 out of here. That gives me 13 over 50. 13 is not divisible by 2. It's not divisible by 5. Simplest form. 13, in fact, is prime. So I'm done. All right. Now we have to be able to go the other way. Fractions to decimals. Okay? So we've done fractions and getting fractions in simplest form. We've done decimals to fractions and getting them in simplest form. Now, if I start you with a fraction, you need to turn it into a decimal. How do you do that? Well, remember that a fraction bar is really division. So really, you just have to do division. Numerator, denominator means take that numerator. I'm running out of room. Take that numerator and divide it by the denominator. Numerator divided by the denominator. Now that looks gross with those words, but let's look at what this means. 11/9, okay, really means this. 11 divided by 9. Oh, hush, don't be such a whiner. You can do this. Put your decimal point in right there first so we don't lose anything. Can 9 go into 11? Yeah, once. Can 9 go into 2? Nope. So you add a 0 and bring it on down. All right, can 9 go into 20? Yup. Make sure you're on this side of the decimal point now. 2. That's 18. I subtract, I get a 2. All right, add a 0 because I'm not done yet. 9 goes into 20. I can do that twice. That's 18. I subtract, I get a 2. Add a 0. Do you notice a pattern here? I'm going to be here forever. Dude, I need to be done with this because I'm just going to keep getting 18s, a remainder of 2. I bring another 0 down. It's 20. All right. This guy is a repeating decimal. So you have to put the bar over the 2. Ta-da. There we go. How about 7/20? 7/20 means 7 divided by 20. Put your decimal point there. Can 20 go into 7? No. No. Put a 0. Can 20 go into 70? Yep. 20, 40, 60, 80, 60. Subtract, I get 10. 10 is smaller than 20, so I did a good job. Put a 0 down. Can 20 go into 100? 20, 40, 60, 80, 100. 5 times. Look at this. That's exactly 100. I have no more remainder. I'm done. Stop. This turns into a decimal 0.35 or 35 hundredths, and it terminated. It stopped. Okay? When you have a fraction and you're turning it into a decimal, it either stops like this or it repeats like that. It's going to happen in one of those 2 ways. Okay? 9/40. 9 divided by, okay, read it like this. Instead of saying 9 over 40, say 9 divided by 40. And then the numerator will automatically get put inside your division bar. Get your decimal point there. 40 into 9, no. Add a 0. 40 into 90, yes. 40, 80, 120, no, 80, just twice. Subtract, add a 0, bring it on down. 40, 80, I can only go twice again, but I get a different remainder, so I'm not repeating it, okay? I have to add a 0 and bring it on down. 40 into 200 is 5. Exactly 200. Done. This decimal was a little longer, 225 thousandths, but it did terminate. Sweet. Here's your assignment. Okay, get onto that textbook. That's the big green book. Open up to page 66, and you're doing these problems. Okay, I want you to get a piece of paper, and I want to give yourself room on each of these. Some of them you can do quickly. Some of them you're going to need more room. So don't just start writing 29, 30, 31 on every single line. One at a time, one at a time. Okay? Good luck. May the force be with you.